In the first stage, the ball attached to the pulley is reeled back from someone with an angle no sharper than 45 degrees to the pendulum. When the ball is released, with no applied force being exerted from the person. Keep in mind, to calculate the exact force applied to the ball, the equation force equals mass times acceleration, Newton's second law, will come in handy. Figure A represents a free body diagram. In the second stage, the first ball, using the applied force from the pendulum, gets knocked down the rail and hits the second ball. According to Newton's third law, when object A hits object B with motion, object B also releases a force directed back at object A, which can be represented by the equation F on B is equal to negative FB on A. A free body diagram of this stage is depicted in Figure B of your reference sheet.
Following this, the ball knocks over the weight that is attached to one end of the pulley. This is modeled by diagram C. The weight falls over the edge and pulls another weight through the string and pulley system. The theoretical calculations for the gravitational potential energy of the falling weight can be found on diagram C as well. This gravitational potential energy is converted to a horizontal force that is applied on the wooden block. The second weight pushes a wooden block across the platform. You can find the theoretical calculations for the force applied on this block in diagram D. When the weight is falling, its gravitational potential energy is converted into kinetic energy.
The wood block tips the tennis ball down a slope. Like stage 2, the sequence of contact between the weight, the wooden block, and the tennis ball can be represented by F A on B equals negative F P on A. The gravitational potential energy of the tennis ball can be calculated using the equation force equals mass times acceleration of gravity multiplied by height. Figure E on your reference sheet illustrates an FBD of the stage. Free body diagram. During this stage, the tennis ball simply knocks the pool ball down another slope. The kinetic energy that the tennis ball had can be calculated by multiplying half of the mass of the tennis ball by the final velocity it was struck by squared. Specifics on this calculation can be found in Figure F.
The ball rolls down the ramp and rebounds off of the wooden piece at the bottom. It then hits the water bottle, which gets knocked over and pours water through a funnel into the glass, completing the purpose of the machine. Despite the splash, water does actually get funneled into the glass.
You see, that's water. Around the pool ball, that's water.
There you go, Mr.
A little bit got in, which is good enough for us, okay? Okay? That's it.